guys, this is Megan again from OnlineMathCircle AIME video tutorials, and today we're going to look at 2009 AIME I problem number 12. In a right triangle ABC with hypotenuse AB, AC equals 12, BC equals 35, and CD is the altitude to AB. Let W be the circle having CD as a diameter. Let I be a point outside ABC such that AI and BI are both tangent to circle W. The ratio of the perimeter of ABI to the length AB can be expressed in the form m over n, where m and n are relatively prime positive integers. Find m plus n. So first of all, I've laid out the figure for the problem here with triangle ABC and points I, tangent segments AI and BI, and circle W with diameter CD. So we're given here that AC is 12, BC is 35, and by the Pythagorean theorem, AB is square root of 12 squared plus 35 squared, which is 144 plus 1,225, which is 37. So AB is 37, and since we know that each leg of the right triangle is the geometric mean between the projection on the hypotenuse and the length of the hypotenuse, we have AD over AC equals AC over AB. So AD is 144 over 37. And so that means BD is 37 minus 144 over 37, which is 1,225 over 37. And so we can go ahead and label these here. Now, so now that we have found the projections, we can now compute the altitude to the hypotenuse of triangle ABC. So in other words, we can use these two lengths to find CD. So the altitude to the hypotenuse of a right triangle is the geometric mean between the lengths of the two projections. So in other words, we have 144 over 37 divided by CD equal to CD divided by 1,225 divided by 37. So CD is equal to square root of 144 times square root of 1,225 divided by 37. And this gives us 12 times 35 all over 37, or 420 over 37. So that means the in radius, little r, of circle W would be half of CD, which is 210 over 37. And so we can go ahead and label that here. Now, next, by the tangent segments theorem, we know that the segments connecting a point outside of a circle to the tangent points on a circle are both congruent. So that means this segment here is also 1,225 over 37. And this segment here is also 144 over 37. Now, let this unknown length over here be x. And by the tangent segments theorem, this unknown length here is also x. So now what have we done? Well, we can calculate the perimeter of triangle ABI in terms of x. And doing so, the perimeter, call that little p, of triangle ABI would be equal to 37 here, plus 37, this plus this, plus 2x, which is 74 plus 2x. And the semi-perimeter little s of ABI would be half of that, or 37 plus x. Now, next we want to, in order to find the perimeter of ABI, we have to find x. So in order to find x, we have to find two possible ways to compute the area of triangle ABI and equate them together and solve for x. One possible formula for the area of ABI is equal to half of the perimeter times the in radius, or in other words, s times r. By doing that, we have 210 over 37 times 37 plus x. And the other way of finding the area of ABI is by using Heron's formula. And for those of you who are new to Heron's formula, say we have a triangle with side lengths ABC, and the semi-perimeter of triangle ABC is just a plus b plus c all over 2. Then the area of the triangle would be the square root of the quantity s minus s times a times s minus b times s minus c. So let's do this for triangle ABI. The area of triangle ABI would be square root of 37 plus x times 37 plus x minus 1,225 over 37 plus x, and that's 144 over 37 times semi-perimeter minus 144 over 37 plus x, which gives us 1,225 over 37, then times semi-perimeter minus AB 37. That leaves us multiplying by x here. Now what can we do now? Well, we can simplify this further down, and that gives us 12 times 35. 12 times 35 all over 37 times the quantity x times the square root of the quantity x times 37 plus x. And that simplifies to 420 over 37 times square root of x times 37 plus x. Now we have to equate this expression and this expression in order to solve for x. Doing so gives us 210 over 37 times 37 plus x equal to 420 over 37 times the square root of x times 37 plus x. We can divide both sides by 210 over 37. And that leaves us with 37 plus x equal to 2 times the quantity, the square root of the quantity x times 37 plus x. And since the semi-perimeter 37 plus x cannot equal 0, we can safely divide both sides by square root of 37 plus x. And that gives us square root of 37 plus x equal to 2 times square root of x. Squaring both sides, we have 37 plus x equal to 4 times x. So that leaves us with 3x equal to 37. And so x is equal to 37 over 3. Now we can find the perimeter little p of ABI, which is simply 74 plus 2x, as we have right here. So plugging in the value of x, we have 74 plus 2 times 37 over 3, which is 74 plus 74 over 3. And adding that together gives us 296 all over 3. And The original problem asks us to find the ratio of the perimeter of ABI to the length AB and express it in the form m over n, where m and n are relatively prime positive integers, and find the sum of m and n. So we have little p all over the length of AB equal to 296 over 3 divided by 37. That leaves us with 8 over 3, which is m over n. So m is 8 and n is 3. And so our final answer is just the sum of m and n, which is 8 plus 3, giving us an ultimate answer of 11.